In this lecture, we are going to create a perfect rectangle. But few other things also we are going to do in this lecture. The first thing that we are going to do is we are going to create a rectangle of 100 mm length and 50 mm width or height and constrain it. So we are going to create a completely constrained rectangle of 100 into 50. And then we are going to find the tool for exiting the sketch application. Once we have completed the rectangle, which is completely constrained, we are going to exit the sketch application. And then we are going to explore how to save the file and open it again. We are going to see some colors and messages that we get during constraining process. Let us start creating the rectangle in CATIA. First, let us close this file that we have created in the last lecture. Just click on this close icon, or I can go to file and close this. It will ask, do you want to save the changes? I don't want to save. So click no. This is the gateway that we had discussed in the first lecture itself, and we will go for file, new. We'll get this dialog box, and here we will select part. You can see part. Click on OK and OK again. Now we have entered inside the part design application of CATIA for a new file. For selecting sketch, I can go to start, mechanical design and sketcher. Also we have an icon in CATIA which represents sketch or the sketcher. You can see. You can also select this icon, and what do we need when we select a sketch icon? We need to select the plane. So let us select any plane. Maybe I'll select this plane, or I can also select this base plane. You can see this is basically the XY plane. So let us select this plane, XY plane. Now we have to create a rectangle. So for creating a rectangle, we require 4 lines. Let us create 4 lines first. I'll click on this profile tool, or you can also go to insert, profile and click on this profile tool. Now I will create 4 lines. Let us click somewhere, maybe here and here, here and maybe here. Press on the escape key to exit from the command and break the chain. You can see. So these are 4 lines. Of course, it doesn't look like a rectangle. Now, by using the mouse middle button, I will move this object by using the pan tool. You can see. Now, when I press the mouse left click, we hold and keep on this line. You can see. This is enjoying all the degrees of freedom. Now let us give the constraints to restrict the degrees of freedom. I have already told you in the last lecture that there are 2 types of constraints. The dimensional constraints and the geometrical constraints. Let us see now what are those types of constraints. Here, these 2 should be connected. So I will click on this point. For multiple selection in CATIA or any other software, you can select the control button. You can see these 2 points I have selected. As soon as I select this icon is getting highlighted, which is the geometrical constraints icon. You will also get the constraints icon here. This is the geometrical constraint icon. You can also click here and you will get this constraint definition dialog box, where only the relations which are applicable to 2 points will be highlighted. All others will be de-highlighted. So we can use distance, fix, coincident. We want to coincide these 2 points. Click on coincidence. Click on OK. And you can see both the points have been coincided. And a green symbol has been generated. This is for the coincidence. The geometrical constraints icon is de-highlighted. As soon as you select this line, it is getting highlighted. Click on this line and you can see all the options, all the constraints that are applicable to a single line has come. You can give length to the line, you can fix this line. This fix constraint will fix the coordinate system of these endpoints and it will be completely constrained. But we don't want that. We should have some liberty. So what do I want to do for this line? I want to create it horizontal. You can see. Click on OK. Now I'll take this line and I want to create it vertical. Click on OK. Now I will take this line and use the control button for multiple selection. Select this line. Both of this line, I want to make it perpendicular. Here I will click on perpendicular. Click on OK. You can see. Now we are left out with only this line. So I'll select this line, use the control button and select this line. For multiple selection, you have to press and keep the control button on the keyboard. Now select this icon, which is the constraint definition icon, and here all the constraints that can be applied to these two lines have come. I want to select parallel. Click on OK. Now it is looking like a rectangle. We can give the dimensions to this, but before we give the dimensions, all this exercise that we have done can be very simple. I will just delete all these 4 lines and again I will take this profile tool. Click somewhere, maybe here. When you move, you can see at a particular area the line is getting locked and the color is changing. This is locking to the horizontal direction, and similarly when you move up, you can see this is locking onto the vertical direction. So when I give this direction and click, this H indicates a horizontal constraint which is getting created for the line that has been drawn. Now we'll move up. You can see vertical, and when you move over here, you can see this is tracking line. The line is getting tracked from this endpoint. You can see. Click and join. You need not create here. You can directly move over and join. So all the exercise that we have done at the start can be nullified by using this tool. So you can use this method to create horizontal and vertical lines very easily. Now let us give the dimensions. Here, this is the dimensional constraint. Click on this. Click here. You can see. Double click on this and we will give a dimension of 50. Now again click on this icon. Click here. Click somewhere here. Double click. This is 100. So we have created 100 into 50 rectangle. Now let us grab hold of this line and move. You can see it is moving. So it is not constrained. It is enjoying the degree of freedom. So what we have to do is, we have to create a relation with this horizontal and vertical axis, or the x and the y axis of this sketch plane. So for giving the relation, we can use any one, maybe the geometrical constraint or the dimensional constraint. Let us take this line and use the control button for multiple selection. Select this axis. We will take the geometrical constraint and both of these objects we want to coincide. You can see. Now the color has changed. This green color indicates both of these objects are constrained. Now let me grab hold of this and move. You can see it is only moving in this direction, that is along the horizontal direction. So we have to give a relation with the vertical axis. Let us give a dimensional relation. Click on this constraints, that is the dimensional constraints. Select this axis and select this line. Double click this to give a dimension, maybe some 50 mm. so that both will be symmetric. Now using the pan tool, I'll move the figure graphic screen. I'll press the scroll and press the mouse right click once to zoom. You can see. So this is a completely constrained rectangle. Now let's move to SolidWorks to create this same rectangle. This sketch we have created in the previous lectures. So let us close this file. I'll close this. Do you want to save all or you don't want to save? I don't want to save this. This is the gateway. Now let us create a new file. I'll click on this new icon. I'll click on part and click on OK. This is a new part file and here I want to create a sketch. Select on this sketch icon and I will select maybe this plane. Now we are inside the sketcher. You can see here sketch 1 of part 2 indicates we are in the sketch 1 of part 2 file. Now let's take the line tool, which is this. Click on line and I'll select here, here. So you can see the method that I am using. Press on the S. Same way that I have used. This is the same method that I have used to tell you about constraining in CATIA. Why I am doing this? Because I want to get aware of the geometrical constraints. So you should always make this type of 4 lines and constrain it to get an idea how the geometrical constraints work. So as we have done in CATIA, we will select this point and this point. So here also for multiple selection, we have to go for selecting control. Now these two are selected and here you can see here selected entities, both of these points. Existing relation means what is the existing relation between them? Nothing. And here we have all the relations that we can give to these 2 points. We can merge these 2 points, which is same as coincide in CATIA. Select merge and you can see. I'll use this close dialog to close this. The figure is completely closed. So in SolidWorks, when there is a closed figure, the inside area is getting highlighted. I will select this line. You just see the method that I am using. This is the same method that I have used in CATIA. And you have to use the same method in any new software to get acquainted with the same type of tools. Now I'll select here horizontal. Again, I'll take this line. As soon as I select a line, this left area is filled with a line properties dialog box. And here we want to add a relation. We will make it vertical. Now we will select this line. Use the control button for multiple selection and select this line. We want to add these relations, but in particular, we want to create a perpendicular relation. Click on perpendicular. Now close this again and select this line. Use the control button for multiple selection. Use this horizontal line. Between these 2 lines, we want to create a parallel relation. Click on parallel. Close this dialog box and you can see. We have very easily created a rectangle. Now as we have done in CATIA, we will delete this. Select all and use the delete key on the keyboard. And now I'll select line again. Click here, maybe somewhere here. You can see the line is getting locked. So we can create a horizontal line. Again, we can create a vertical line, a horizontal line, and you can track this point. And we will close this. Press on the escape key to exit from the command. Now press the control key on the keyboard and the mouse scroll and move this rectangle to center of the screen. Let us give the dimensions. So we will use this dimensional constraints. Out of this we can use this smart dimension. Click on smart dimension. Click on this line and let us give a dimension which is 50. Press on the enter key. Again we'll select this line and give a dimension 100. Press on the enter key. A 100 into 50 rectangle has been formed. Now is it constrained? We will check by holding any line. Press the mouse left click or mouse left button and move. You can see it is not constrained. Again, if you hold this line, it is not constrained. So we have to tie them with the horizontal and the vertical axis, which is this. Now here we don't have the axis. We are just seeing the symbol. But we have an origin here. In the left side, here in every software you will find a part navigator which will contain a history of the things that you are doing. You can see this is the sketch one which we are right now creating. And these are the three planes. Let us zoom a bit. You can see these are the three planes. All are hidden. So what we can do is we can select these three planes, right click, and we want to show it. Here this eye symbol indicates show. You can see now all the three planes are visible. By using the scroll, I am rotating the figure. You can see all the three planes have been shown. They are not hidden anymore. Now we'll select here and use plane normal. We have our axis now. We can use this as an axis and this as an axis. And of course in this plane we are now working. We'll select this line, use the control button for multiple selection and use this plane which will act as an axis. And both of this, what we want to do? We want to create a collinearity between them. Press on the escape key to exit from the command. Now if you move this, we need to give a relation with the vertical axis, which is this. And here also you can see these two lines have changed color. Earlier they were blue, now they have converted into black, which indicates both of them are constrained. Now I'll just hold this and move, maybe somewhere here, and give a dimensional relation between this plane and maybe this line. I'll give a relation maybe some 50 mm. You can see here. You can also select these three planes, right click, and this is hide. So all the three planes will be hidden. So this is completely constrained geometry. Now that we have created a completely constrained rectangle of 100 into 50, the next step is to find the tool which is used for exiting the sketch application. Now in SolidWorks we have to find the term exit sketch or exit workbench or exit application. Anything with a exit. You can see first we will move over to the left top corner. Here we have this exit sketch. Just click on this and the sketch has been exited. You can see the color and the dimensions have gone. So this is the solid modeling application of SolidWorks. Now similarly I'll go to CATIA. Now this is CATIA, and as I have told you in SolidWorks, there is a part tree where it will store the history of whatever we are doing in this file. Also it will contain the planes. You can see these are the three planes, XY, YZ and ZX, and here body which represents a solid body. Now let us find the exit workbench. So if you move over here, there is no exit workbench here. If you come over here, you can see exit workbench. You can click here, or you can also go to start, mechanical design, and you can select part design. You will exit automatically. But let us click on this exit workbench. You can see now we are in the part design interface for creating solid modeling inside CATIA. Now that we have exited Sketch application, let us save the file. Now in CATIA, I will go to File, Save As, and in Desktop, I will save this file as Rectangle. Click on Save. The file extension for a CATIA file will be CAT part. Click on Save. In SolidWorks, here we will go to this file, Save As, and we'll go to Desktop. Here also we will save this file as Rectangle. The file extension for solid part file will be SLD part. Click on Save. You can see here the file name is given here. Let us close this file. So now the SolidWorks interface is completely clean and the gateway has been displayed. Similarly in CATIA, we will close this file and this is the gateway. Now let us open the file. Click on File, Open. I'll go to Desktop and we have the file here. You can see rectangle.cat part. Click on Open and the file has opened. Similarly, we'll go to SolidWorks, click on Open, we'll go to Desktop and here we have rectangle.sld part, click on Open and the file has opened. Suppose we want to enter inside the sketch. You just have to double click on this rectangle. We have entered inside the Sketcher application of SolidWorks, which contains the rectangle that we had constrained. In CATIA also, when you double click on this sketch, you can get into the Sketcher interface. Now let us discuss the colors and messages that we get during constraining. This figure is completely constrained in CATIA. Suppose, let me take this line, use the control button for multiple selection and take this axis. When you select this and go for coincidence, click on OK, you can see there are some colors. This color indicates inconsistent geometry, which indicates that you have already given a dimension 50 from this line to this axis. Again you are saying that these two are coincident. So it is an inconsistency. So either you delete this or you delete the constraint which is coincidence as displayed here. You can remove a constraint in CATIA by just selecting the geometrical constraint or the dimensional constraint and use the delete key on the keyboard. Suppose I want to delete this geometrical constraint which is coincide. Click on this geometrical constraint and delete. You can see now it is green again. So green indicates the geometry is completely constrained. So you will get many errors or messages and also these colors which indicates you have not given the constraint properly. Let us take the dimension. Here I have given from this axis to this line as 50. Suppose I'll take this axis and I'll take this line. You can see this is called over constraining. Already we have given 50 here and 100 here. So why we need to give 50 here? 50 plus 50 is equal to 100. So any one of these three we should delete. We can select any one and delete. So suppose I select this dimension and delete. Now the figure is okay. So you get colors when you give over constraints and also you give some inconsistent constraints. So whenever you face any colors or any messages, that indicates you have not done the constraining properly. So just check your drawing. In SolidWorks also, if you see here, let us bring back our plane. I'll bring back this front plane and again this plane. You can see these two are the planes. Now here I'll take this line and I'll take this plane and both of these can be made collinear. Click on collinear. Here there are some messages. there are so many colors here, and here there is also a message, the sketch is over-defined. Click here to resolve the conflict. But we know what is the conflict. So, you can select here in over-defined and diagnose. So, it will give you some options to solve your problem. The first option that it gives is, you can see here there are two results. First option is, accepting the solution will delete the following relation. So, this distance will be deleted. You can see. But we don't want to delete the distance. Now, the next solution is, you can delete this collinearity. So, you can just accept this. Now, your sketch is okay. Let us undo. There is also a shortcut. Because we know what is creating the over-constraining, so we can select this edge, and you can see here all the relations that have been given to. So we can delete this collinearity. As soon as you select this collinear, you can see both. Now just right click and delete. Now you can see the sketch is completely constrained. In SolidWorks, a completely constrained line or a object will be of black color. In the next lecture, we are going to practice on a simple example so that we will get a clear picture on constraining, on creating some geometries, and also the interface of the CAD software.